Okay, so I originally created a garage door opening system with a Raspberry Pi using a 5-volt relay and a reed switch. But looking at it from a budget standpoint, I think there's a better solution. The Raspberry Pi is pretty expensive, they're hard to get. It's a very interesting tool for doing this project with, but I think it's a little overkill, especially that you can run an entire operating system on a Raspberry Pi. So I'm going to redo this project, and what I'm going to use is an Arduino board. One of the reasons why I'm doing that is I just don't really want to maintain the security and the operating system on the Raspberry Pi. And I would like to be able to use the Raspberry Pi for other things. So looking at how to do this with an Arduino and the cost of an Arduino board, to me it seemed like the right choice. I run into issues down the way, I can always move back to using this Raspberry Pi. But I think these Raspberry Pis are like $100 versus you can get an Arduino board for 17. So part of that thought process also was, I'm going to be keeping this in a garage where there is moisture from cars that are coming in after being rained on. In the summer, the humidity in the garage, it's not an air conditioned area. So I really don't want to keep a $100 device in a garage. So yeah, that's what the plan is. All right, so I've got the Arduino set up now, and I've been playing around with it. I've written a couple of examples working with the serial port and setting up a function. I haven't set up the LED, like I haven't done a beginner LED with any of the pins or the relay or the reed switch yet. A couple of things to note. So I wanted to capture what I've been developing in the IDE and kind of what I've seen so far. So let me swing over to the code. Okay, so kind of going over the code a little bit here. Actually, what I want to do is I want to get this tripod set up. I know it's bad that I'm recording my screen. Oh well. All right, so that should be set up static. Shouldn't move now. All right. So a couple of things that I've done so far. Serial.begin, setting it up to 9600. I'm going to come back to that in a second. I have been playing around with reading bytes off of the serial interface on the Arduino. I wanted to eventually write a string basically to this is going to be communicating with the server, so I didn't really want bytes, I kind of wanted strings, but I think strings are going to be a lot slower for this project, and I might actually resort to using character values or bytes, but I'm still in the early phases of this. So basically right now I have the serial port set up, and I can read a string off of it into this string variable right here. And then basically if it matches hello with the \n, it prints out got hello. And the other thing I did is I wanted to set up functions and just kind of figure out how they work. So I have this hello world function that just basically prints hello world. One of the things that I noticed is 9600 is kind of a little bit slow. The other thing is the Arduino is a little bit slow manipulating strings, and I kind of want this to be somewhat fast when you go and want the garage door open, or if you want to read the sensor to see what the position of the garage door is. I don't want that to take super long, but I could be splitting hairs with the timing. A couple other things with the Arduino IDE. If you want to verify your code, like if you have a bug, how can I create a bug? Like here, if I uncomment this line, so technically I don't have this variable declared. If you hit this check mark, that didn't do it. Oh, sorry. If you hit this check mark up here and do verify, it'll actually check your code before you deploy it to the board. And basically that way you're not pushing bad code over to the board. I'm sure there's some limited capabilities with that. It's not going to detect runtime errors, but I've found it pretty helpful in developing those. So I'm going to push this code over to the board. And then what you can do is you can bring up the serial monitor here. And you can see on setup, it's the initialized part of the board. The loop is the thing that runs constantly. So you can see it prints hello world. So if I print, it's hard to do with the camera. If I print hello like that and hit enter, it says I received got hello. I know this is bad. I just threw it all together. And then if I print this, and then I hit enter, we get a different message. So got hello is what we're looking for there. So we didn't return got hello right there. I do notice that it's kind of slow. So if I send hello again, it's like 2 seconds to get a response back. It does seem to be a lot quicker if you're not working with string manipulation. You know, this isn't like a super powerful processor on this board. It's a microcontroller, so I may resort to not using strings, but I'll continue to test that. A couple other things I found cool is when you open up the serial monitor, it actually restarts the board, which makes sense. These boards work off of you can reset them with this red switch if you want to re-execute code, or like for instance, if you start the serial monitor, it resets the board automatically. That way you go through all that setup functionality. There's the two main functions, setup and loop. So opening up the serial monitor will execute setup again. So I'm going to do that real quick, and you can see I just opened up the serial monitor, so you see the orange light flash, and then it comes back to a static light, and that basically reset the board and re-executed the code. Okay, I realized, I think I forgot to mention about the baud rate. So I did try changing the baud rate to, let me take a look and see, 115,200. And it did seem to speed up the text portion a little bit, but the string manipulation that's having to happen on the board isn't necessarily the quickest. So let me push this over and kind of show. Back to serial monitor. Okay, why is this not working? I can't really tell. I don't really think upping the baud rate affects the speed at all. So I think I'm going to keep it at 9600, but more to come. Okay, so the next day, I was able to get the RS-485 serial working. And to kind of go through what I've got here, this is a Max RS485 board, and basically it takes 5 volts in and then ground here, and then there's 2 other terminals underneath that you can't really see right now. I'll show you on another board. And then those terminals are A and B. They're tied to this terminal block right here, so I'm not using the pins that are below. And that is going to a RS485 to RS232 adapter. And then obviously the RS232 adapter plugs into the computer. Why am I using RS485? First off, because it's cool. No. It has a longer communication length. That's an acceptable limit. RS232 has a limit of 50 meters or 50 feet. I can't tell. I think it's 50 feet. 50 feet. RS485 has a limit of like 1,200 feet. And there's some other similarities too. Like RS485 uses just 2 conductors, whereas RS232, you got to have a serial port with however many pins are on there. There's some challenges in using RS485 to communicate with the Arduino, and I found those out after studying, and that's kind of why I wanted to put this together. I went over the 4 pins that are here. There's another set, let me grab this. There's another set of 4 pins in the back here. There's a DI and an RO pin. The DI is the leftmost pin and the RO is the rightmost pin. And those are connected to, DI is connected to the transmit pin, and RO is connected to the receive pin. And when I set this up and used the terminal software that's on my computer, I was able to get the output, the first print statement that I have that says Arduino initialized. But I was never able to send any of the commands over. And later, after researching, I found out that I needed to have the DE, which is this middle left pin. I needed to have DE and RE. RE is the right middle pin. I needed to have those combined together from what I had read online. So I tried doing that and none of that worked. So I finally had to work really early this morning. So a little tired. Been up since 2:30 a.m. That didn't work. But doing a little bit more research this morning, very early, I found out that not only do you have to tie these together, what you have to do is you have to supply a high-low voltage, basically, if you're transmitting or receiving. So RS485 can work in half duplex mode, and that kind of makes sense. So what I'm going to have to do is use one of the GPIO pins to control the voltage across here. And that's kind of just where I'm at right now. So in the little testing that I've done, I didn't set up a GPIO pin. What I did is on my breadboard, there's a positive and a negative rail, if you will. So what I've been doing is I've just manually been, providing a high voltage of 5 volts to here and then removing it. And sure enough, believe it or not, I was able to transmit and receive doing that. Now, it's still not calling my function, and that function is a blink function, which blinks this LED right here. And I'm not sure if I showed that in the previous clip. So what I was hoping is to be able to trigger that from the RS-232 485 interface, not the Arduino interface. I'm getting close. I think it's just like a carriage return or line feed issue. That's how close I am. I just need to sort that part out. What I am going to have to do is every time I print something out, I'm then going to have to take another one of those GPIO pins, and after I print the message, I'll need to set the GPIO pin to, I'll have to figure out which is high, which is low, meaning which ones transmit and which ones receive. But I'll set the GPIO pin basically to say, okay, set this circuit to receive, and it'll just sit there and wait for a command. And then once it receives a command, it'll move it to transmit and then send it back through. As far as software that I'm using for the RS-232, I'm a Linux user, so I'm using PicoCom and Minicom. And for the RS-232 interface, I don't know, that's it right there. And I'll get a better screenshot of it in a second. For the RS-232 interface, I didn't really have to set anything super special for it. 9600 baud. I kind of left the parity bits alone. I didn't really figure out the carriage return line feed. There's a way to set that in there, but honestly, it might be easier to just set it in the code to delete the new line. Maybe not even use the new lines. Gonna work with that a little bit more, but that's the next step in the code. This interface right here is just a dongle, and then there's 4 wires that you can use for RS-485. I'm only using 1 and 2, which are A and B. This one of these is a ground, and I think one of them's 9 volts, so we don't want the 9 volts or the ground. We're just using the A and B. And that's just connecting to this board. I'm using just a spare twisted pair cable, like Cat5 cable, and I'm just using 1 pair off of there, the green pair. Seems to be working. So yeah, that's the current update. Let me show you kind of what I want to do for the garage as far as like the project box when this is finalized. Okay, obviously I'm trying to do this on a budget. I mean, I could just use the Raspberry Pi, then I wouldn't have to use RS-485. I could just use a Ethernet cord. I also don't like the fact of the Raspberry Pi being like an over-engineered solution and having to update the operating system on the Raspberry Pi. Although this RS-485 stuff was a little painful, I've been able to work through it, and I still think that this is a good solution. For my project box, what I got was one of these extra duty weatherproof outlet cover for outside, and the Arduino is not that thick or not that deep of a board, and as you can see, there's a good 1 inch inside of this box. I like it because it's got a clear cover. Right now it's all packaged up, and I can set it to open up horizontally or vertically. I think I'll keep it horizontally, but I'm still figuring all that out. The big issue with this box is on the back. It's meant for like a GFCI outlet, and obviously I want something that's a little bit flat. So looking around online, I was able to find this is a cover, like a weatherproof cover for a junction box. And basically I started to size it up, and I think I'm going to be able to put that in the back and make this pretty much a project box. Sorry, the gasket goes that way. Probably will remove one or both of the gaskets. Still gonna figure that part out. But yeah, I think that's a pretty good project box. And this was one of the cheapest ways to come up with this. I was looking on Amazon, and there's another really nice project box that's like $18 that's got metal clasps and a clearer lid. This solution was 10, so it saved about $8. And I think the other project box would have been a little larger, plus I would have had to drill for holes. This one has slots so that I can open them up and feed the cables in, or drill through these. And then I should have a somewhat weatherproof case that I'll be able to, put the Arduino in. So kind of next steps are to finalize this. I think I'm gonna edit this video, put it together. It's going to be the first video on the channel. A little bit about that. I am not an electrical engineer, so this isn't really representative of what I want really to be on the channel. I am a programmer, like system support person day to day, so it's very odd that I'm picking an electrical project for my first video. The reason I'm picking this is I found this interesting and I wanted to bring it to the internet. Maybe it'll help somebody else out in what they're working on. So I think this will be the first part. There'll be multiple parts to this because I'm now seeing the scope of this whole project as the scope creeps. One thing is these RS-485 boards are a little bit unwieldy to work with. They don't really fit on a small little breadboard like that. I'm thinking about how to productionalize this as well, and how I'm going to fit key pieces inside this box. It's always in the back of my mind. Obviously, looking at the Arduino, that's going to fill up a good portion of the box, but I'll be able to put the RS-485 module here in the relay, and then we'll need to get the reed switch in there as well. I haven't even gone over that part of it. So yeah, let's talk about these RS-485 boards. Alright, so I'm going to have to put the camera down and open this one. Okay. So on the back side, oh, this one's bent. Wonderful. The back side of this board, you can see there's 4 pins on each side. So we talked about on this side, there's the 5 volts, the B and the A terminals, which are also tied to these blocks, this terminal block. So sorry, the B and the A pins are tied to the terminal block. That's what I meant to say. And then there's a ground. So this is like the incoming RS-485 signal that's coming from the computer. Then on this back side is the DI, DE, RE, and RO pins. So the outer pins are going to transmit and receive. And then the inner pins, I have them bridged together, and I'm supplying a high and a low, and that triggers if this board is in transmit or receive mode. And yeah, see, this is all bent up. So anyway, putting that next to the Arduino, you can see it's not super big, so that should easily fit in the box. Yeah, I'm gonna cut the video here. I think I'll make this a part 1, And yeah, I'll keep you posted. Haven't written anything special code-wise for the serial ports. I will show that again in the next part. The other thing, I was doing some reading, and I kind of suspected this. The string library is pretty inefficient on these microcontrollers, so we'll have to figure out a way to maybe just accept bytes or keep the strings to a very minimum. It was pretty slow when I was working with it, and I'm kind of an efficiency person, and it was a little too slow. So, we'll see. If functionality suffers, then I'm going to take functionality over the slowness of the string library. But yeah, I'm going to cut the video there. Thanks.